And slope-intercept form is y equals mx plus b. And in that, m is your slope. It should be a fraction, right? It's the coefficient of x. M is your slope. The plus b, right, because sometimes it's minus, plus b or minus b, whatever that is. B is your y-intercept. It's your plus or minus number. It's called the constant. All of it's a review, right? We learned all of this yesterday.
Yeah.
If it's written in slope-intercept form, it's super easy to graph. But guess what?
You're gonna make it harder.
It's not always written in slope-intercept form. It's a little trickier. So you'll probably have a problem that looks like this. 6x plus 2y equals 10. In order to graph, it must be in y equals mx plus b. I cannot graph this the way that it is. Now, yes, we learned, if it's written in standard form last week, we learned that you could do the intercepts, right? You could cover up 6x. So what's your y value? 2 times what is 10? 5. So you go to y-axis and put a dot at 5. Ooh. What's your x value?
6.
No. No. 6 times what equals 10? It's a decimal, right? I don't know. So I really don't want to graph this using intercepts because it's got these decimals in them that I don't want to have to do. So we learned a little while ago how to solve for a variable. So could you take this equation and solve for y? Yeah, let's do that. There certainly must be a way.
Question.
Algebra. To get y alone, I first move out my 6x. So I subtract 6x from both sides. And on the left side, I'm left with 2y equals. And on the right side, what do I have? This is why it was so important. I stressed so much when we were doing it variable first. Because in y equals mx plus b form, your variable's first. But I'm not done because y is not by itself yet. I'm going to divide by 2. So the 2's cancel out, and I'm left with y equals, what's negative 6 divided by 2? Negative 3x. What's 10 divided by 2? Positive 5.
Wait, so this is like what we learned in graphic functions part 1?
Yep.
Good job.
So take a graph Because now I can graph this line. And Dylan said, isn't this what we learned in Graphing Functions Part 1? You're right. But in Graphing Functions Part 1, we then took this equation and made a table, right? We made that big old table and substituted values, but we don't have to make that table anymore. Because this is linear. Now, if this problem had two variables in it, on this side, if it had x and z, I couldn't use slope-intercept form. If it had an x squared, it had an exponent in it, I could not use this shortcut. I'd have to go back to the function table. But it doesn't have a variable, or it doesn't have an exponent in it. I'm good to go. I'm going to start with my y-intercept, which from this equation is what? What's your m and what's your b? M is -3. Make it a fraction. -3/1. What's your b value? +5. From this equation, I found my b value, which was +5, and my slope, which is -3/1, because slope has to be a fraction. So I start at 5. Y equals 5, and I do my slope, which is -3. So what does that look like? Go down 3, 1, 2, 3. And +1/1. I'm going to go down 3, 1, 2, 3, +1. I'm going to do this as many times as it fits on my graph. Because the more dots, the straighter your line. The more accurate your graph is. Can I put more dots up top, up here?
Yeah.
How do I do that? I flip the positive negative around. Instead of -3, it becomes +3. And instead of +1, it becomes -1. So I go up 3 and backwards 1. And there's my line. Way faster than making the function table, picking 4 values, substituting those 4 values, simplifying and getting an answer, then graphing those ordered pairs. Okay, so what if it gave you a problem like this? All right, write the slope-intercept equation. For the line that has a slope of 4 and passes through the point 2, 5. Write the slope-intercept equation for the line that has a slope of 4 and passes through the point 2, 5. All right, so slope-intercept, that means it has to be in y equals mx plus b form, correct? That's slope-intercept form.
Yes.
Okay, let's substitute. What do we know? I know the slope is 4. 4 over 1, right? So instead of the variable m, I'm going to put 4. All I did was substitute the slope because it told me that. What else do I know about this problem? What do you know, Anna? Okay, that's close. But if it was the b, it'd be 0, 5, correct? And it's not 0, 5, it's 2, 5. This is not an intercept. But Anna brings up a good point. 5 is your y value. So that makes 2 what? 2 is your x value. So can you, using those numbers, fill them in somewhere? Looking at this equation, I did my slope, which was 4. But where could I put the 2 and where could I put the 5? I wonder where I could put the 5, which is your y value. Where could you substitute 5 in for y? Not b. B is your intercept. Right here.
Oh my gosh.
5 equals 4. Where can I put my 2? No. My x value. Times 2 plus b.
What's B, Miss Long?
What is b? 5 equals, what's 4 times 2? 8 plus b.
Did I hear a B?
5 minus 8 is -3 equals b. So now can you fill in y equals mx plus b form? Y equals, what's your m? 4. X plus b, what's your b value? I didn't really write that in the best spot because I want to graph that now.
I like that too because you were there. Nice job.
Sorry. All right, take your graph. We've done this before. We can get creative. Just glue half of it if you did what I did so it, folds back. Sorry. Then graph it. Boop. It's right there.